Alright, today is another MCA lesson for 7th graders, and we hadn't quite gotten to circumference and area of circles, so that's what we're going to talk about today. And it is something that they've seen before, but we want to make sure we hit it again before the MCAs come up, because these two things are on our formula sheet and they will be on the test. Okay? So when we talk about circles, the first two things that we want to talk about are the radius and the diameter. Remember, the radius is half of what the diameter is. Okay? And the radius extends from the center of the circle out to an outer edge of the circle. Okay? And you can have as many radii as you want to. This is the radii, radius. Okay? All those little segments would be considered a radii, or a radius, okay? Because they extend from the center to an outer edge of the circle. So basically, this distance, if we were to take it and go all the way around, the radius would be the same. It's from any point on the outside to the center of the circle, it's the same distance, and that's what we call the radius. Now the diameter goes all the way across, so it touches two ends of our circle, but it has to go through the center. And that is double what our radius is. And how we eventually get to circumference, I will explain in a little bit. But circumference is the distance around our circle. Okay? We're going to relate the diameter to the circumference of our circle in a second. So basically, circumference is a fancy word for perimeter. But when we talk circles, it has its own name, and we call that circumference. Okay. So actually, where all this will come into play with the formulas we're going to see today is we're going to get to a special number. And thousands of years ago, it says here, mathematicians investigated a question, and it was how many diameters equal circumference. Okay? And they found that the answer did not depend on the size of the circle. The circumference of every circle is slightly more than 3 diameters. Oh, you're fine. Yep, no, I'll just keep going. It's fine. Don't worry about it. And it doesn't matter what circle you use, and you'll see in this diagram, or Mrs. Luther, she'll be, it's fine. You'll see here that if we took any circle, let's take this middle one here for instance, this to this would be a diameter. So they took this diameter of the circle and they tried to spread it out around the outside. And they found out that it takes about, so here's one diameter, here's another one, and here's another one. Okay? So it's about 3 diameters to equal the circumference around the outside. But you can see in each circle here there's a little bit extra that it didn't quite reach. Okay? So the number that it actually is a very popular number today, and we know it as pi. So the extra amount needed is about, not exactly 1/7 of the diameter. Thus, the number of diameters needed to equal the circumference of a circle is about 3 1/7, or as an improper fraction, 7 times 3 is 21, plus 1 is 22, 22 over 7, or 3.14 as a decimal. And we know that, like I said, as pi. And pi is not a variable, it is a constant, because the value does not vary, the value does not change. Okay? So the actual circumference of a circle is pi times however many diameters we have. Okay? And it's important to know that these are approximations for pi, they're not exact, let's see, word I'm looking for, exact, they're not, well, basically I'll just say that they're not exact, okay? Pi goes on forever and doesn't repeat. It's a decimal that keeps going. There's actually competitions to remember as many digits as you can. And so we can use 3.14. It doesn't give us exact answers, but we can get very close that way. So let's actually see what this looks like. Okay, so they give us the radius of a circle is 10 centimeters. What is the circumference? So we have a radius, and it is 10 centimeters. However, this formula calls for the diameter, not the radius. Now remember, the radius is about half of our circle, or it is half of our circle, okay, or at least through the center. So our diameter has to be double that. So our diameter equals 20 centimeters. So we plug that in. We do circumference equals pi times diameter. We're going to use 3.14 for pi and multiply it times our diameter. So 3.14 times 20, if we do that, we get 62.8 about centimeters. So the distance around that circle, if it has a radius of 10 centimeters, is about 16.8 centimeters around. Now, another thing that they're going to bring up is we're not always going to use just 3.14. They might tell us to use something else. Now, I told the students it doesn't matter to me unless, you know, the MCAs tell you to use a specific amount for pi, but I think that it'll just mostly be 3.14. Okay, so if we set this one up, letter A, it says use 3.14 for pi. So circumference equals pi times diameter. This is the full distance across through the center, so 30 inches is our diameter. We'll do 3.14 times 30, and that should give us our answer. Okay, I'll do that on my calculator real quick. If I can find it. Oh, it's on this side here. So 30 times 3.14 is 94.2. And we are in inches. So distance around that circle would be 94.2 inches. Now letter B says use 22/7 for pi, and here's the reason. Our diameter is 14 feet. So pi, we're going to use 22/7. We're going to multiply that times 14, our diameter. I'm going to change it to 14/1. And you'll see how this works out. 7 and 14 can cancel. 2 7s go in here, 1 7 goes into 7. So we have 1 times 1, which is 1. 22 times 2 is 44. So this is 44 feet. So the reason they had us use that was because, or 22/7 was because it came out to a whole number. Now our last one, remember this gives us a radius, so we want a diameter. And this will also be a 10. So diameter equals 20. And this one says we can leave pi as pi. Sounds kind of funky, but it actually is easier. So we just leave pi as pi times our diameter, which is 20. And I'm going to flip these around because it doesn't matter which order you multiply in. 20 times pi centimeters. Alright, so that's just leaving pi as pi. You don't have to do the multiplying step. So that's 3 different examples using 3 different values for pi. That's circumference. And now we're going to talk about area, which isn't a whole lot different, other than the fact that we're talking distance around. Area, we'll be talking about how much space is taken up on the inside. Okay. Now way back when, they were also trying to figure out the area of a circle. And they started off by drawing a square with the radius as sides. So here's 2 radii. And so if we find the area of the square, we can see there's a little bit left out. Okay, that piece right there. Okay, we don't want that, but if we found the area of that square, that would be a part of it. So we don't want this piece left over, but that's kind of what happens. And I'll show you what they did with this. Instead of just doing about a fourth of your circle, they went ahead and they did a full circle, and they figured out that, okay, now one thing I should have mentioned is the area of this square would be r times r, or length times width, and r times r is r squared, okay, radius squared. Okay, now if we do this with 4 squares, we can see that we get r squared for this area, this one, and this one, but we have these little spots that we don't want the area of, because we just want the circle area. Okay, so this stuff we don't want, and what they came to find out was that any circle you took, it was the area of less than 4 squares, but bigger than the area of 3 squares. Okay? So the circle is less than the area of 4 of these squares. However, the area of the circle is more than the area of 3 squares. Well, guess what number it came out to be each time they did this? Oops. Sorry about that. Oops. The number of squares whose area exactly equals the area of the circle is between 3 and 4. The exact number comes out to be pi. Thus, to find the area of the circle, we first find the area of the square built on the radius, then we multiply that by pi. Okay, so summarize the equation. Area of the circle is pi times radius squared. Okay, and again we have 3 examples that are similar to the last ones, except for circumference, except for now we're looking at the radius, not the diameter. Radius is half of our circle through the center, 10 centimeters, so area here equals pi r squared. We're going to square our radius, we get to use 3.1 for pi, or 3.14, 10 squared, so 10 to the second is 100, we have 3.14 times 100, because 10 times 10 is 100, and if we do this, 3.14 times 100, we get 314, and we are in centimeters squared. Centimeters squared because we are with area now. Alright. Letter B says we get to use 22 over 7 for pi again. So we want area equals pi times radius squared. We get to use 22 over 7. And if we square 7, our radius, 7 times 7 is 49. So I'm going to do 49 over 1. And we get some canceling we can do again. 7 7s going here, 1 7 goes into 7. And we get basically 22 times 7. And if we do that, we get 154. So 154 inches squared. Alright, and lastly, we have to leave pi as pi, which means we don't have to do the last step of multiplying. And so we just need to do pi times radius squared. Our radius would be, our diameter is 12, so our radius is 6. 6 is halfway. So we square 6, and we get 36. And our area then is 36 times pi feet squared. Alright, so that would be the answer for C. Alright, so that's just a little review on our circle area and circumference, and we will see you next time.